Kirk math. All right, ladies and gentlemen, here we go. This is our last lesson, our last set of notes for Module 12. Today, we're going to use that Pythagorean theorem as a tool once more to find the distance between 2 points on a coordinate plane. So let's dive right in. Key terms. We need to remember everything that we need to know about Pythagorean theorem. You should have all this memorized. So we're first going to start with the formula. So you should be saying this with me. A squared plus b squared equals c squared. This is our formula. This is the thing that we need to remember and memorize. Okay. And then we need to apply. What does that even mean? We should know what A, B, and C even mean in a right triangle. Only right triangles. A and B are what? The legs of the triangles. And that means that C is my hypotenuse. Hypotenuse. C is directly across from that right angle. It is the longest side of my right triangle. And then A and B are directly next to my right angle. Those are those legs. So as long as we remember all of this information, we can use it to apply to our problems today. All right, so here is our problem. So over here, I have a figure drawn on a coordinate plane. And we are going to approximate the length of the hypotenuse to the nearest tenth. So I'm going to go 1 decimal place using a calculator. So approximate means that we're just kind of get an estimate of that answer. Obviously, the real answer has is an irrational number. It's not going to be a perfect square. So that's why we're going to use that calculator to help find the square root in order to solve for and get the information. So basically, we're doing the same thing we did in lesson 12.1, except that this shape is on a coordinate plane. I know that this leg of my triangle is 2 because it is 2 spaces on the coordinate plane. And I know that this leg of my triangle is 4 because it is 4 spaces on my coordinate plane. What I don't know is what the distance between these 2 points right here is. So this point here, let me get a different color or something so you can see it a little bit better. This point here and this point here, I need to know the distance between those points because it is not perfectly on a line on my coordinate plane. I cannot tell how long it is. If I count diagonals or anything, that doesn't work. So what I need to do is use the Pythagorean theorem. Given 2 sides of a triangle, I can find the missing third side. So this obviously is the hypotenuse it tells us, which means that the thing I'm missing is C. So in my formula, I know that C squared is going to be the thing that I'm missing. Okay. The first step that I needed to do was find the length of each leg, which we already did here, 2 and 4. And now the next step, which I'm going to do up here, but is to basically let A equal 4 and B equal 2, label your legs. C is the hypotenuse, which is what we're trying to find. So we're going to plug them into the theorem and solve. So I'm going to have 4 squared plus 2 squared equals C squared. I'm going to draw that mirror line straight down because that's going to help me see my 2 sides. Because C is the thing I'm missing, it's going to see the 2 sides. Because C is the thing that I'm missing, I'm just going to solve the left side of my equation, and then I should be able to figure out what C squared is. So let's go ahead and do that. 4 times 4 is 16. 2 times 2 is 4. That equals C squared. Now I'm going to go ahead and add these 2 things together. 16 and 4 is 20. And you should immediately know that 20 is not a perfect square. So when I do this square root, I am going to have to approximate and round to the nearest tenth my answer. So I'm going to go ahead and pull out my calculator. I am going to do 20 and my square root button. And look at this huge number I get, but I only care about 2 decimal places after the decimal point. So my answer for C is going to be 4.47. And you can see I rounded that here. The 7, if I look to the right, that's a 2. So my 7 rounds down. 4.47 is going to be the answer. So that is approximately the distance of this hypotenuse right there. All right, we're going to do this again, but notice that on this your turn question, they do not give me the lengths of my legs. So that's where that first step on the previous page, step 1, over here, step 1 comes in handy because you have to actually figure it out. But because it's on a coordinate plane, I can just count the hops, okay, count how many spaces it goes. So I'm going to look here. I've got one, oops, let me get a pen out. There we go. I've got 1, 2, 3, 4, 5. So this leg is 5. 1, 2, 3, 4. This leg is 4. And when you're doing distance problems, you're almost always going to have that hypotenuse be the thing that's missing. C is almost always going to be the thing that's missing because we can count our vertical and horizontal lines. Vertical and horizontal, but I cannot count these diagonals. I don't know what the distance is. So that's why we're using the Pythagorean theorem. Again, we're going to go to the 10th and we're using a calculator. So I'm going to write out my theorem, my equation. I know that c squared is the thing I don't know. And I'm going to go ahead and pick. Well, let's just let the 5 equal a and the 4 equal b. So I'm going to do 5 squared plus 4 squared equals c squared. I'm going to solve the left-hand side of my equation. So 5 squared is 25, 4 squared is 16. I don't know what c squared is. We're going to add because it's on the same side of the equal sign. Let's see, 6 and 5 is 11, and that's going to be 41 equals c squared. And again, I know this is not a perfect square, so that's why we're going to round to the nearest tenth. But I am going to do the square root. So I'm going to do 41, square root button, and you can see it's going to be 6.40. Well, it's just the tenth, so 6.4. Okay, so I'm going to have C equals 6.4. And actually, did I forget? I think on this page, they wanted to the 10th as well. That's right. That was supposed to be the 10th, so I probably should have changed that there. We should pay attention to the instructions given. But still, that is my answer. All right, here we go. We have another word problem. And as you can see, this drawing is drawn kind of on a coordinate plane so that we can see the lake and everything. I'll read the problem in a second. But they're giving us points. They're not telling us the actual distance. I can't count here. So I'm going to show you how we can find the legs of this triangle given coordinate points, but not given actual measurements. So Francesca wants to find the distance between her house on one side of a lake and the beach on the other. She marks a third point forming a right triangle as shown, and the distances are measured in meters. So if, as a reminder, our points here are X and Y, okay? X and Y, X and Y. To find the distance between 2 points, I need to know, am I on the X or the Y axis? So because I'm going horizontally, I am looking at the change in X. So the distance here of this line would be the X from the 280 minus the X from the house. That's going to tell me the distance of, let's call this B. Okay, so the distance of leg B is going to be 280, the X from this third point minus the distance here. Okay, kind of like when we found slope and we subtracted those distances and those points, it's kind of the same idea here. So I am going to subtract, I'm going to get 270. Now the distance for A, which is what we're going to call this leg, is because I'm going vertically, I am changing in my y-axis. You can see my x's are the same, so I don't want to subtract those. I'm going to take the y's here, okay? And I am going to subtract those. So I'm going to do 164, take away 20, and that's going to make 144. Okay, so now that I have those two measurements, I can use them in my formula. A squared plus b squared equals c squared. And if you think about it, what we just did was we found the lengths. This would have been step 1 up here. We found the lengths of the legs. Sometimes you can count them, sometimes they give them to you, and sometimes you have to do a little extra work. So I know that the length of A is 144, and I need to square that. The length of B is 270, and I need to square that to make C, which is the distance between her house and the beach, in a direct line. Okay, now I can solve. I'm going to need my handy dandy calculator for this one because I don't know what 144 squared is. I know the square root, but I don't know what its squared is. So it's going to be a really big one. 20, let's write this down. Bam. Okay, as you can see, I took a break and kind of solved this out so we didn't run out of time. But basically, I just used my calculator to find these answers here. I added them together to get 93,636. Then I used my calculator to find the square root of that, and that was 306 meters. So the distance between her house and the beach in a straight line is 306 meters. All right, so now we're going to have a problem where they give us 2 points and we had to graph them on the coordinate plane. So if you noticed, I skip counted by 2s because I have 3, 7, 15, and 12, and it just wasn't fitting on my graph. But I skip counted by 2s and I plotted a point here, which is at 15, 12. And I plotted a point down here, which is at 3, 7. And we need to find the distance. I need to know what this is right here. Then if you notice, I plotted a third point that makes a right angle, which means it's directly below the 15, and it's directly to the right, or sorry, yeah, directly below here, the 15, 12, and directly to the right of the 3, 7. That means that my y coordinate is 7 and my x coordinate is 15. So this point is 15, 7. Okay, I'm going to do the same thing I did on that last problem in order to solve. I'm going to find the distance between these. Now I could count, but because I skip counted by 2s, I might get a little confused, but I'm just going to do 12 take away 7 because those were my y-axis. My y's here, those are the things that are different. And that's going to tell me that this, which I'm going to say is A, is 5. And then B, which is going to be down here, again, I'm taking the numbers that are different, the 15 and the 3. And that's going to tell me 12 is the distance down there. So A is 5 and B is 12 and C is I don't know. And I'm just going to go ahead and do 5 squared plus 12 squared equals C squared. And we're going to solve that to see what it equals. And as you can see here, here's my work. I squared the 5 and the 12. I found the square root of the 169 to get C by itself. And that makes 13. So the distance between these 2 points is 13. So the last thing I want you to do is try out this problem right here on your own, and then you've done all the practice you need. Remember, sometimes they're going to give you the distance, sometimes you can count them on a coordinate plane, and sometimes they give you the coordinates and you have to do some subtraction to figure out the distance between them. But see if you can find the distance between the Camp Sunshine and this person's house, Francesca's house, to the nearest 1/10 of a meter. All right, so if you found the distance between the house and this extra point over here, you would have seen that the x value over here was 10 to 200, so that's a difference of 190. The a value, which I did as the y value, I did a difference between 120 and 20, that's 100. I plugged them into my equation. Don't be afraid of big numbers. It makes sense that they would be really far away because we're dealing with meters and distance. So we're going to get into the 10,000 meters. Basically, when you add them together, you're going to get 46,100 meters. I found the square root in the end. I didn't write that, but I did that on my calculator, and I got 214.7 to the nearest 1/10 of a meter. So that is how far the house is from Camp Sunshine. So I hope that that made sense to you, and remember to bring your questions to class so that we can go over them.